Hi everybody, in this video we're going to talk about the geometric definition of a parabola and we're going to do some examples. So a parabola is the set of all points in the plane that are equidistant from a fixed point F, the focus, and a fixed line, the directrix. So I put some pictures here from our textbook just to help illustrate. And so the focus is this point right here, point F. And so the idea is that that distance from point F to the parabola is the same, so these two lines being congruent, to the distance to this line. The line L is what's called a directrix. And then we have the vertex of the parabola. So up until now, we know how to find the vertex if a parabola is in standard form. But how do we find the focus and how do we find the directrix? So that's what this chapter is going to be about. And so here's another picture identifying the points of interest. So we have the focus is the point 0p, and the directrix is, so the focus is above the vertex or on the inside of the parabola, and the directrix is a line the same distance away as the focus is, but on the outside of the parabola. And so that's the directrix. And so again, these lines, the distance from the focus to any point in the parabola is the same as the distance from that point on the parabola to the line, to the directrix. And so that's what we are looking for. So that P is how we can find the focus and the directrix. So when the parabola has a vertical axis of symmetry, so that will be like these two graphs. The parabola has a vertical axis of symmetry, then the graph of the equation is x squared equals 4py. And you can get that by doing the distance formula. So we're saying that these two distances have to be the same. So we would do the distance here, so from the point 0p to the point xy. So the distance here will be the square root using the distance formula, right? So it'll be x minus 0 squared plus y minus p squared. So that will be that distance. And so we're saying, so x squared plus y minus p squared has to be the same as the distance of this line segment from the blue line, the directrix, all the way to the parabola. Well, this is a y distance. So this distance here is y, and this distance here is p. So it should be the distance, so the absolute value of y minus a minus p, so y plus p. And when you solve this, so square both sides, right, I'm going to have x squared plus then y minus p squared equals the absolute value of y plus p squared, which when you square an absolute value, this will just be y plus p squared. So I have y minus p squared and y plus p squared. So when you multiply this all out, I'm going to have y squared minus 2 yp plus p squared equals, and then when you square that out, you get y squared plus 2yp plus p squared. And so when we try to combine like terms, notice that if I subtract the y squares from both sides, my y squares actually cancel. If I do the same thing with the p's, so try to get the p squares on the same side, my p squares are also going to cancel. So the only thing that is left is I'm going to have x squared on this side. And then if I add this 2yp to the other side, I'm going to have equals 4yp, which is this equation here. So that's where the equation for a parabola with vertical axis comes from. That's where it comes from. So this parabola then has the property that the vertex is at 0, 0. There's no shift. And the focus is the point 0p, because our vertical axis will be at the y-axis at x equals 0. And the directrix is the y equals minus p, right? Once I know the focus, then I go that distance up p, and then we go the same distance on the outside of the parabola to get the directrix. So here's a better picture. So this will be vertical axis is the line, the y-axis, which is x equals 0. And so that's our focus, and then that's the directrix. So again, that distance there is P, and that distance there is P as well. So when P is a positive number, then the parabola opens upwards. So when P is greater than 0, parabola opens up. And when P, the focus, is less than 0, then the parabola opens down. And when we have a horizontal axis parabola, so we could do the same thing. So a horizontal axis parabola is when the axis of symmetry is horizontal. So here are a couple of graphs. So the parabola essentially opens sideways. It either opens to the right or it opens to the left. And if we do the same thing that we did up here, but with the horizontal axis parabola, we will get the exact same thing, but it will be y squared, right? It will be x minus p squared plus y squared equals x plus p, the absolute value. And so we're going to get this equation, y squared equals 4p squared. So one way to think of it is if you have y squared, it's a horizontal axis parabola. If you have x squared, it's a vertical axis parabola. There are no shifts here, so the vertex is at the origin. The focus is now, because it's on the x-axis, is p is the x value and then 0 for the y, and the directrix is an x equals minus p. So we have these two. Same thing here. When p is greater than 0, the parabola opens to the right. And when p is less than 0, the parabola opens to the left. Remember that the focus is inside the parabola, so if the focus is positive, then the parabola is going to open towards the positive side. If the focus is negative, the parabola is going to open towards the negative side. And same thing with a vertical axis. When the focus is positive, that means that the P is on the positive Y, so the parabola is going to open towards the positive Y, so up. And if the focus is negative, that means that the point P is on the negative Y-axis, so the parabola is going to open downwards. It's going to open towards the negative Y values. So how do you work with these equations then? Let's try an example. Say I want to graph the parabola 16y equals x squared. So the first thing we got to think about is this a horizontal axis or a vertical axis? Notice that I have x squared. So this is going to be a vertical axis parabola. And so I know that the equation is x squared equals 4py. So we just kind of compare. So usually this is what I do. So compare the standard equation to what we have. So I have 16y equals x squared. So if we want, we can rearrange it so that it looks, so just switch the sides so that it looks like that. So I have x squared, so that's good. So those match up. And now I have 4py, this is 16y. So can you figure out what p is? Yeah, right, we can say this is x squared equals, I gotta get that 4 in here. So 4 times what gives me 16, and then I have the y. So in this case, we can easily see, well, 4 times 4 will give me 16. So that means that p is equal to 4. But the other thing that you can do when it's not so easily seen is that you can say, well, I want my 4p to equal the 16. So you can create an equation and say 4p equals 16 and solve for p. Divide both sides by 4. So p is equal to 16 divided by 4, which is 4. And so now that I have that, we can graph our parabola. So since p is positive 4, that means that the focus is going to be on the positive, so this opens upwards, right? P is positive, so it's going to be a parabola that opens upwards starting at the origin. And now the directrix is the line y equals -4. So if we draw this line, oops, so this will be the directrix. And now the thing here to make sure is that when you draw this parabola, the distance from the focus to a point in the parabola has to be the same as the distance to the directrix. So I don't know that I'm going to do a very good job here, but it kind of has to be a little bit wide. Not too bad, it's a little sideways, but bear with me. So so if I go there, then the idea is that these distances are the same. That distance from the focus to a point in the parabola, right, this is any point xy, is the same as if you drop the perpendicular directly to a directrix, those distances should be the same. And so that's what we're going to be looking for. So this is the focus, which is the point 0,4, and the directrix is the line y equals -4. So let's try another example. All right, so for this second example, graph y equals 2x squared. So again, think about first, is it a vertical axis or horizontal axis parabola? I still have x squared, so this is still a vertical axis. So that means I want to look at my equation, y equals 2x squared, and compare it to the standard, which is 4py equals x squared. So I don't have a constant here, so my first thing is going to be to get rid of that 2. Divide both sides by 2 to get just x squared. So x squared is going to be equal to 1/2 y. And so now it kind of looks like that. So this is a good example of when to use our equation. So I want 4p to equal 1/2. So those should be equal. So we can say 4p has to equal 1/2 and solve for p. Divide both sides by 4 or multiply both sides by 1/4. So p is 1/4 times 1/2, which is 1/8. So that is our p, which means when we go graph it, this is, we said, a vertical axis parabola. And so the focus, because p is 1/8, the focus is the point 0, 1/8, and the directrix is the line y equals -1/8. So we're going to go somewhere over here, 1/8, and somewhere down below the same distance, draw your directrix. And so the parabola, the vertex is at the origin because there are no shifts, and then we can draw to the best that you can your parabola. And again, the idea is that the distance, when you go from the focus to any point in the parabola, this distance should be the same. So what does a horizontal axis parabola look like? Let's try an example of that. So for this example, or examples, part A, we want to graph 8x equals y squared. And so we want to look at, they're both y squared, so these are going to be horizontal axes. So they're going to open sideways. So let me just scroll back up to, say, horizontal axis looks like y squared equals 4px. And the vertex is 0, 0 because there are no shifts here. In the following sections, I think it's section 11.4, we're going to look at what do parabolas like this with the shift look like. So the focus, now notice that the x is p and the y is 0, and the directrix is a vertical line, x equals negative p. But the 4p still stands. So here I have 8x equals y squared. So let's start with a. So I have 8x equals y squared. So we want to compare it with the standard, which is for px equals y squared. I know the book has, or what I have above is y squared equals 4px, but just reverse it and it's the same thing. And so looking at this, I have x, I have y squared already alone. So with these types of parabolas, we want to get either the y squared by itself or x squared. Whatever the square term is, we want to get that one by itself. And so now notice that essentially I want my 8 to equal 4p. So that's what we want. We want 8 to equal 4p, and then solve for p. So divide both sides by 4, so p is equal to 2. So that means that our focus is going to be, this is a horizontal axis parabola, so that means that p is an x value, so it'll be 2, 0. And the directrix, it's a vertical line, so it will be the line x equals negative 2, right? The opposite side, the opposite of the whatever the focus is, whatever the p is. And so when we draw this one, let me see if I can draw it over here. Is it going to open to the right or to the left? Well, I usually put my focus first. So this is 2, 0. And remember, the focus is a point that's on the inside of the parabola. So the parabola is opening towards the focus. So because the focus is on the positive x-axis, that means that our parabola is going to open to the right. And then the directrix is the line x equals negative 2. So from here, I'm going to draw my directrix vertical line. This is x equals negative 2, the directrix. And then we draw a parabola with the vertex at 0, 0. And I think I should have drawn it a little bit wider because remember my points, this distance and this distance should be the same. And so that's the graph of that parabola. So let's try part B. B is x equals negative 1/2 y squared. So notice that the y squared is not by itself, so solve for the square term. So solve for, in this case, y squared. If it was x squared, I would be solving for the x squared. So multiply both sides by negative 2. So I'm going to have minus 2x equals y squared. Now that I have the y squared by itself, compare to the standard, which is 4px equals y squared. And the reason that it's nice to compare it is because now I can see, okay, the coefficient of the x here is 4p, the coefficient of the x here is negative 2, so I want negative 2 to equal 4p, and solve for p. So divide both sides by 4, so p is negative 2 over 4, which means that p is negative 1/2. So this is what helps us find the focus and the directrix. So now I know that the focus, and because this is a horizontal axis parabola, again, this is going to be, the p is now an x value, so it'll be negative 1/2, 0. And the directrix is the vertical line, x equals the opposite of p. So negative and negative, so positive 1/2. And so we go to graph it. And again, I always plot the focus first. So the focus is negative 1/2, so it's going to be somewhere here on the inside. And sorry, on the left. But what I was thinking was the focus is on the inside of the parabola, so the parabola opens towards the focus, so this is a parabola that's going to open to the left. And then our directrix is going to be here at the line 1/2. Sorry, that's not a very good line, but and then draw the parabola. And then just kind of make a little drawing to indicate that we understand that that distance and that distance, those distances are the same. And so our focus, that's the point F, -1/2, 0, and the directrix is the line x equals +1/2. And in the next section, we're going to do the ellipses and then hyperbolas in the next section. But hopefully this helps understand a little bit about the focus and the directrix.